Let's have a look now at graphing linear equations or linear functions. Linear functions look like straight lines when we graph them. Now, there's 4 things that I would highly recommend you have, okay, as part of your toolkit. You'll need one of these, okay, make sure it works, okay. I'm going to highly recommend that you draw your graphs in pencil, okay, originally. Chances are you'll probably make a mistake and you'd want to be able to rub that out and redraw it. So you do that in pen, it'll become a lot harder to modify if necessary. If you make a mistake with a pencil, you'll need one of these, okay? And of course, you're drawing a straight line, so might I recommend you have a ruler and a clear one at that. Okay, this ruler's had a bit of use, which is good. So it means it's been put to good use. Don't use a wooden ruler. I'd highly recommend. It's good to be able to see through the ruler as well, so you can see the grid. All right. Here are some linear equations or linear functions that we're going to look at. Just 6 examples. Of course, there's unlimited examples that we could do, but here's some 6. I guess a choice of 6 different types that you could see. Okay, y equals 2x minus 3. We're going to graph y equals 2 minus x, y equals 2, x plus y equals 3. Notice this is not in the form y equals mx plus c, but does that matter? Not really. X minus y equals 2, so changing a plus to a minus. Wonder what that does. And y equals x. Nice and simple. All right, now just to make life a little bit easier for us, I've prepared some grid paper and I've drawn in the table of values already just to save a bit of time. And let's begin. All right, so the first one is y equals 2x minus 3. Now there's 2 ways that we could graph this, in fact. For those of you that recognize y equals mx plus c or minus c, but the form y equals mx plus c, you could in fact use the grid paper directly. So what you could recognize is this minus 3 or this negative 3, that would be the y-intercept. All right, so you could in fact put a sort of an x. So I'm just going to put an x there on the y-intercept. All right. Otherwise, you could fill out the table of values and I'm going to draw a line. You'll see that it'll pass through that. The other thing to note as well is that the gradient is 2. So what that means is that for every step across, so from left to right, and gradient's always measured from left to right, every step across, we go 2 steps up. Every step across, we go 2 steps up. Step across, 2 steps up, so on and so on. Okay. Otherwise, we could just fill out the table of values, plot 4 points, make sure the points all line up. That way we haven't made a mistake. So all 4 should line up on a line or should sit on a line, and we draw the line in between. That goes through the points, sorry. So let's start. Let's use our calculator. All right. So y equals 2x minus 3. We're going to substitute one by one each of these x values. Now, by the way, the x variable is also called the independent variable. Okay, and the reason for that is it's kind of like we have control over the x variable. We could make these values whatever we want. You might ask, how come you chose -1, 0, 1, and 2? Could I use anything I like? Yeah, actually you could. At least in this example, it doesn't really matter. You could use 1,000, 2,000, except it probably won't be practical given the grid that we have there. So I could have chosen -3, -1, 1, and 3. I just chose these values just because they're convenient. All right. So without further ado, let's substitute in these values. So 2x minus 3, 2, okay, times -1, okay, that's a negative sign there, -1, okay, minus 3, and we get -5. Now, 0 is a nice number, okay? So when I say nice number in maths, it doesn't do much, which is kind of nice, right? So in multiplication, it actually does even less than adding 0. In fact, anything times 0 is 0, isn't it? So 2 times 0, okay, is 0 minus 3 is -3. Incidentally, when you substitute 0 into an equation that's in the form y equals mx plus c, you'll get the y-intercept, in fact. And that's kind of nice. Right? The y-intercept occurs when x is 0. So I might just maybe put a little sort of an annotation there. This is the y-intercept. And I said that earlier, didn't I? That the y-intercept, -3, you could read that straight out of the equation, couldn't you? Okay, let's keep going. 2 times 1, all right, is 2 minus 3. 2 minus 3 is -1. And 2 times 2, so it's 4. 4 minus 3 is 1. Okay, what you should notice as well is that the numbers, the y values seem to go up by 2. So -5 to -3 to -1 to 1. That's what the gradient does. The gradient says for every time we step up 1 step in x, we're going up 2 steps in y. So across, up 2, across, up 2, and so on. All right, let's plot some points. So we said the x variable is actually represented by the horizontal axis, also called the independent variable. The y value is dependent on the x value. So what do you think is another name for the y variable? If you said dependent, well done, all right? So that's independent because we can make these values whatever we like, and the y values have to be calculated from that. All right, so let's start. -1, -5. So this is the coordinate -1, -5. Make sure you get these around the right way. X, Y. -1, -5. Okay, and an X marks the spot. 0, -3, we already have. So we already saw that from before. 1, -1. Okay, so x equals 1, go down to -1 there. And you can see the pattern starting to form. All right, 2, 1. All right, so 2, 1. The dots look like they line up, or the x's. Okay, if they do, you're reasonably satisfied with that. Okay, get a ruler. Okay, I just put little arrows on the ends there. The line goes forever. And another good habit to get into is to write the equation next to the line. The reason for that is because later on we'll have a look at graphing simultaneous linear equations. Okay, where there's two lines and we need to find out where they cross, and it's kind of nice to know the equation of the line or that represents it. All right, so this equation, y equals 2x minus 3, which is in algebra, could be drawn in graphical form as a line. They represent the exact same thing. All right, this relationship between y and x could either be expressed using algebra or could be expressed using a picture, and that's why we have two different forms to represent the exact same thing, just the relationship between two variables. Right, let's have a look at the next one. Y equals 2 minus x. That doesn't look like y equals mx plus c, doesn't it? It sort of looks like the x is sort of, it comes after. We should have had to put that before. If you want to, you could rearrange that. For those of you that want to just get straight to the graphing side of things, we could rearrange that as y equals. You could swap the negative x and the positive 2 around. Negative x plus 2. So we have a y-intercept, in fact, of positive 2. So I've just rearranged it in the form y equals mx plus c. So that way it just looks, hopefully, a little bit more familiar. All right. I might just zoom in on that a little bit. That's a bit better. Okay, hopefully you can see that a bit better. Yep, I can. Right, let's fill up the table of values again if you like. Okay, so and have a think about the gradient as well while you're at it. Negative x, negative number, predicting a downward. If you're saying that the line should be downward or should go like something like that, you're probably right. Let's confirm that. Okay, let's substitute in some points. 2 minus x, when x is negative 1. 2 minus minus 1. 2 minus minus, double minus, plus, 2 plus 1, 3. 2 minus 0, 2. 2 minus 1, 1. 2 minus 2, 0. Okay, you can see the pattern there, all right? As x goes up by 1, what are the y values doing? The y values are going down by 1. And that makes sense. The gradient here, the m, okay, is equal to negative 1. Okay, the y-intercept is in fact 2. Right, let's plot some points. Negative 1, 3. Negative 1, 3. 0, 2. And that makes sense from the y-intercept that we've determined when we rearrange the equation into the form y equals mx plus c. Okay, let's keep going. 1, 1. So that's here. And 2, 0. And that's there. Right. I think I'm reasonably confident that the points all lie on a line. All right. Okay. Right. And I'm going to label it y equals 2 minus x. Okay. It helps to keep your graphs neat and tidy, okay? It's something that I have to say that I do get disappointed when I see sloppy looking graphs. Take some care with it, okay? And I think you'll find then that you're more likely to get not just to get the answer right, but it's less likely to be misinterpreted as well. So if you do things freehand, for example, it might look like a curve. Well, a curve's not a sort of a straight line in that sort of definition of the word. So we want a straight line to be a straight line. Okay, next. We got 2, sort of y equals 2. I think that was the part C and D. Okay. So y equals 2 and x plus y equals 3. So let's start off with this one, y equals 2. That's an interesting one. Where's the x value? Now, you might think, can we express this in the form y equals mx plus c? Guess what? You sure can. This is really the equation y equals 0x plus 2. What's the gradient? Gradient 0. What does a gradient of 0 look like when it's graphed? Looks like a horizontal line. It's a level gradient, isn't it? Right? Kind of like a level playing field. Well, in theory anyway, if any such thing exists. Nothing's, well, I don't know if anything's ever perfectly level, but level enough for our practical purposes. Now, when y is equal to 2, that means it doesn't matter what the x values are. 0 times negative 1 is just 0. 0 plus 2 is 2. 0 times 0, that's a nice easy one. 0 plus 2 is 2. 1 times 0 is 0, plus 2 is 2, and no surprises, this one's also going to be 2 as well. So that's going to give us, in fact, a horizontal line passing through the y-intercept of 2. So we could, in fact, plot a few points if you like, 0, 2, 1, 2, and 2, 2, and so on. Okay, so... Okay, forgot to mention before, as part of your toolkit, you probably need one of these as well. Okay, I'm going to rummage through. You'll need a sharpener. Okay, so pencil starts to go blunt, you sharpen it. Now, let's label the equation. You might think, I forgot to label it. No, I didn't. Here we go, y equals 2. All right, next one. X plus y equals 3. Now, you could just graph it like this if you like, and just substitute in the points and solve the equation for the y values. Or if you want to, you could in fact rearrange this into the form y equals mx plus c as well. So leave the y where it is. This x, it's because it's a positive x, right? That's actually a plus x. You could subtract x from both sides. So this is in fact 3 minus x. Does that look familiar? Looks like that one, doesn't it? So I'd expect a graph that looks quite similar. Okay, let's fill out the table of values. So I'm expecting a graph with a gradient of -1. So kind of a graph that looks a bit like that. Oop. Stay there, pencil. All right, like that, and a y-intercept of 3. That's it. -1. Okay, so let's substitute -1 into the equation. So -1 plus y equals 3. I might just do a couple of lines of working here. So -1 plus y equals 3. Add 1 to both sides. Okay, y is equal to 3 plus 1. Y is equal to 4. Okay. When x is 0, 0 plus y equals 3. Well, 0 doesn't do anything with addition, at least. It sort of represents nothing. So y is equal to 3. Okay. You could probably see, or you could probably guess as to what's going to happen, like an educated guess. 2 and 1, isn't it? In fact, I'm just going to fill the rest of that in. In fact, 1 plus 2 gives you 3. 2 plus 1 gives you 3. 0 plus 3 gives you 3. -1 plus 4 gives you 3. So that's a good way to check. All right, let's plot. So -1, 4. Okay, -1, 4. We've got 0, 3. 0, 3. That's our y-intercept. 1, 2. Okay, so that's there. And 2, 1. Just there as well. All right. Let's draw a line that goes through those points. Okay, and we can write down the original equation, which is x plus y is equal to 3. Okay. Happy with that? All right, last one. Okay, maybe I'll just zoom in on the table of values there. So next one is x minus y equals 2. Okay, this one, let's see what it's going to look like compared to the last one. All right, the last one was an x plus y, this is an x minus y. All right. We could, if you wanted to, rearrange the equation if you like. For those that prefer the algebra, let's do that. So let's move the x over to the other side. So we'll have negative y, okay, is equal to 2 minus x. But we don't want negative y, we want positive y. So I'm going to multiply both sides by negative 1. So what does that do? Multiplying by negative 1 will make the negative y into a positive y. Multiplying 2 by negative 1 will make the 2 into a minus 2. And multiplying a negative x by a negative 1 will turn it into a positive x. So we in fact have y equals negative 2 plus x. Swapping those two around, we have y is equal to x minus 2. Okay. So those that are a bit more algebraically inclined can go, okay, that's nice. Well, that's a gradient of 1 with a y-intercept of negative 2. So that's why the y equals mx plus c form is so good, is because you can see the gradient, you can see the y-intercept immediately. Okay. Anyways, for those that would like to see the graphical way of doing it, let's just fill out the table of values like we've done before. Okay. A nice number to fill out first, you don't have to do the table of values in order. You can do the 0 first because that's easy. So 0 minus y equals 2. Okay, so in other words, when you put x equals 0 in there, it's like the x disappears altogether. Negative y equals 2, multiply both sides by negative 1, you get y is equal to negative 2 in fact. Okay, so 0 minus minus 2 will give you 2, so that's your way of checking it. What about when x is negative 1? All right, so negative 1, okay, minus y. So I'm running out of space here a little bit, but might just do it, do some working out here. Negative 1 minus y is equal to 2. Okay, another way you could look at this is you could move the negative y over, make it a positive y, and move the 2 over, make it negative 2. Okay, so 2 can go over, becomes a negative, the negative y goes over, becomes a positive. Negative 1 minus 2 is equal to y, that's negative 3. Okay. What about 1? Okay, I'm going to use a little equation here again. So 1 minus y equals 2. Okay, y will equal negative 1. In fact, add them. 1 minus minus 1, minus minus is a plus, is equal to 2. And lastly, 2 minus y equals 2, y has to equal 0. Alright, another way to check that again, and I think we've done this before, add them together, or subtract them, sorry. 2 minus 0 gives you 2. 1 minus minus 1 gives you 2. 0 minus minus 2 gives you 2. Negative 1 minus minus 3. Okay, so when I say negative 1 minus minus 3, so negative 1 minus minus 3 will give you 2. Okay, that's all I mean by minus minus. Alright, let's plot some points. So you know what the y-intercept is going to be. It's going to be negative 2. So 0, negative 2. By the way, that's the first thing I would say, sort of as a word of advice. Start off by plotting the y-intercept, because that could be worth 1 mark in itself. Could. I'm not saying it will be necessarily, but it can be worth a mark because it actually is a correct point on the line. All right, we got 1, negative 1. So 1, negative 1. Okay, 2, 0, comma 0. Yep. 2, comma 0, so that's there, and negative 1, negative 3, just there. Okay, the points look like they'll line up, so let's line them up and draw the line that passes through those points. Okay, using a nice sharp pencil. Okay, I would recommend either HB or 2B, by the way, if you're using a pencil. The H is a bit hard, you may have to press fairly hard into the paper and you risk actually tearing the paper. So that's why I find that either HB or probably 2B, you don't have to apply so much pressure. It just makes it a bit easier to draw a line without tearing into the paper. All right, last one, y equals half x. Oh, this one's a fairly straightforward one. This is half x plus 0. Okay, so this means that the y-intercept is in fact going to be 0. It's going to pass through the origin, in other words, 0, 0. Let's see. Substituting the points into this equation, the x values. Half times -1 is just -half. 0 times half is 0. 1 times half is half. And 2 times half is 1. So I would expect a line that passes through the origin, 0, 0. Okay, so I might actually just put the point there. And whose gradient is half. That means it takes, for every, 2 steps across, you go 1 step up. 2 steps across, 1 step up, and so on. Now, another point, if you don't like to bother with fractions too much, let's do let's plot the whole numbers, or the coordinates that are whole numbers. So 2, 1 is there. We can plot the points that are halfway, sort of between the markings there. So -1, -half. So -1, -half is probably around there. So you can just do that by eye. And 1, half is around there. So you can estimate that as best as you can. Could use a ruler as well to measure it. Okay, so depending what you have time for. If you've got time, you can use a ruler, obviously, but you don't have to be super, super precise as long as it's fairly close. Okay, and you've got 2 points that you know that you can plot quite easily anyway. The other ones are just more to verify that you've, in fact, got these points that are whole numbers, or that use coordinates that are whole numbers correct. Okay, back down there. Okay, put the little arrows on the ends because it goes forever and ever. Okay, and we'll put we'll write the equation. Okay, y equals half x, and zoom out, and that's it. We've now plotted 6 lines. In the next video, we're gonna go and do things in reverse, where I'll give you some lines, and you will need to work out the equation of the line. Thanks for watching.